but I want to make a video explaining all these questions. So number one, everybody, you might have to write it on a separate sheet of paper. There's not much space. You can't zoom in as much as I do right here on the video. So when we have a radical, a square root, and a fraction on the inside of that square root, we are able to split the radical. So you put the square root of 9x up on top, and you put the square root of 5x squared on the bottom. Okay, so it really kind of becomes like two problems. Okay, now let's focus in on the top problem, which is the square root of 9 and x. So what I'm going to do is I'm going to split the square root. That way I could actually do the square root of 9. What's the square root of 9? 3. And the square root of x you can't mess with, so I'm just going to leave it like that for now. So up here on the top, we have a 3 square root of x. Now on the bottom, if I were to take that, and let me do it over here on the side as well, the square root of 5x squared, and if I were to split them and I put the square root of 5 and the square root of x squared, I could actually do the square root of x squared. What is the square root of x squared? X. So I really have an x on the outside, and the square root of 5, you can't do anything with that. So you would just leave it like that, but you want to rewrite it in order. So in the denominator, we really have x square root of 5. You can't, hey guys, you cannot leave a radical in the denominator. So if you want to get rid of that square root of 5 on the bottom, what do we have to do to get rid of that square root of 5 on the bottom? Multiply both top and bottom by that same exact square root of 5 value. So up on top, I could actually multiply the square root of x times the square root of 5. I could put those together underneath one square root. So my answer up on top will be 3 square root of x times 5 is 5x. And on the bottom, we have x times square root of 5 times square root of 5. What is the square root of 5 times square root of 5? Square root of 25, and the square root of 25 is just 5. So in reality, on the bottom, we really have x times 5, which is 5x. 5x. Once again, the square root of 5 times the square root of 5, that's just 5. So you have x times 5, that's 5x on the bottom. And that's your answer to number 1. Kind of challenging. You're going to have one almost exactly like that on the test Friday, so please understand it. Okay? Let's look at the next one. The next one's a little easier. Let me zoom in even further. Of course, maybe I need to think about it. Number 2, you have the square root. It's kind of blurry right there, but we're going to split the square root to each of the terms. So I'm going to have the square root of 32. I'm going to have the square root of x to the 4th. I'm going to have the square root of y squared, and the square root of z to the 7th power. Now remember, a square root is the power of 1/2. Okay? So I really have x to the 4th to the power of 1/2, because a square root is the power of 1/2. So if you have x to the 4th to the power of 1/2, a power to a power you multiply, right? Now maybe I should show my work here. X to the 4th to the power of 1/2. Well, we know that we need to multiply the power to a power, and 4 times half is 2. So whenever you're doing the square root of any variable term with the power, it's kind of like just dividing by 2. So you end up with x to the 2nd power. Okay, so it's this easy, guys. When you have the square root, that's really the power of 1/2, so it's kind of like dividing the exponents by 2. So what's the square root of y to the 2nd? That's just y. How about, we totally forgot about the square root of 32. 32 is not a perfect square number, so I need to rewrite it with multiplication to get a perfect square number. 4 times 8 works, but there's a better perfect square number than 4. 16 times 2. So if you go 16 times 2, and then we split the root, that'll be 4 square root of 2. Now let's go to this last one over here, the square root of z to the 7th. Now, you know that the square root is the power of 1/2. So in other words, you want this 7, you want the 7 to be divisible by 2. So you're going to rewrite it. You're going to rewrite z to the 7th as z to the 6th times z. That's the same thing as z to the 7th. Are you with me? So when you split the root, the square root of z to the 6th, that is just z to the 3rd, because 6 divided by 2 is 3. And the square root of z, you're just going to leave it the square root of z. Now, let's take a look at all of our answers so far. We have 4 square root of 2. We have this, no square roots. And we have z to the 3rd square root of z. So we're going to take these square root values and put them together underneath one square root. I'm going to take that square root of 2 and the square root of z, and I'm going to put them together underneath one square root, which is going to be a 2 and a z in there. And then I'm going to take the values that are on the outside of the square root and put them all together. I'm going to take this 4, write it right there. I'm going to take the x squared y, and I'm going to take the z to the 3rd, z to the 3rd. Ladies and gentlemen, this is our final answer for number 2. Is it easy?
Yes.
The more you practice, the easier it gets, right? If you did well on that test that we didn't input, then you should be pretty good on this section. Number 3, we're going to split the root again. And again, you guys don't have enough space. I don't even have enough space, and I'm zooming in all crazy. You're going to need to do this probably on a separate sheet of paper. The square root of 5m, we're going to split it, the square root of 8. So it's kind of like doing 2 problems. If I asked you, could I do anything with this numerator? Could you do anything with that? No. It's not a perfect square number. You can't rewrite it with multiplication. You can't even, it's not an m to the 2nd where you could actually divide it by 2. So it's just the square root of 5m, that's going to stay that way. But on the bottom, we could do something. The square root of 8 could be rewritten as the square root of 4 times 2, right? And when you split the root, you'll actually get 2 square root of 2 on the bottom. Okay, so my bottom is going to change from the square root of 8 to 2 square root of 2. The top is going to stay exactly the same. So on top I have 5m. On the bottom I have 2 square root of 2. A lot of us think we're done. That's our answer. But that's not our answer. Why is it not our answer? Can't have a square root on the bottom. So how are we going to get rid of that square root of 2 on the bottom? Multiply both sides with that same square root value. So on the bottom, I'm going to have, let me write my answer in black right here. On the bottom, I'm going to have the 2 right there times, but what is square root of 2 times square root of 2? It's the square root of 4, which is what? 2. So again, when you multiply a radical with itself, the square root disappears. When you multiply a square root with itself, the square root disappears and the number stays. So on the bottom, I'm really going to have 4 as the denominator on my answer. Now up on top, I still need to multiply the square root of 5m times the square root of 2. Put it all together underneath the one square root, I will get the square root of 10m. So let me write it all in the same color. The square root of 10m over 4, that's your final answer right there. Square root of 10m over 4, that's your final answer. Let's take a look at number 4. We're going to split that root. So we're going to say the square root of 20, and we're going to say the square root of a, and we're going to say the square root of b to the 5th. So square root of 20, what do I rewrite that as? 2 times 10? No, 4 times 5. Why 4 times 5? Because 4 is a perfect square number. And when you split it, you'll actually get a nice, beautiful number 2, no more square root. So I do have 2 square root of 5 when I simplify square root of 20. And then the square root of a is just going to come right down. And now you want an even power. You don't want b to the 5th. So if you don't want b to the 5th, let's rewrite it so we could have an even power. So I'm going to take the square root of b to the 5th, and I'm going to rewrite it as b to the 4th times b, and I'm going to split the root. Because b to the 4th times b is b to the 5th. And when we do the square root of b to the 4th, what do we get? What's the square root of b to the 4th? B to the 2nd, because 4 divided by 2 is 2. And then the square root of b just comes down. So what we need to do now is put all the terms that are on the outside of the root together in front and all the terms that are inside of the root together underneath one root. So my final answer for number 4 is going to be 2b squared square root of 5 times a times b. 5ab. Let's move on to number 5. That one's super easy. It's not a perfect square number. By the way, the Casios could do this for you. The Texas Instruments cannot. Anyhow, the square root of 75, it's not a perfect square number. Let's rewrite it with multiplication to get a perfect square number. 25 times 3 is the same thing as 75. When you split it, you'll get 5 square root of 3 as your answer, and that's it. Let's jump to number 6. Determine whether each sequence is arithmetic, geometric, or neither, and explain. So we need to check if there's a common difference. If there is a common difference, that's arithmetic. We need to check if there's a common ratio. If there's a common ratio, that's geometric. So remember, to do that, it says on the board, you pick a number and subtract the number before it. Or you pick a number and you divide it by the number before it. So I'm going to take 4 and divide it by 12. 4 divided by 12, that reduces down to 1/3. So maybe my common ratio is 1/3. If I try 12 divided by 36, 12 divided by 36, that also reduces down to 1/3, right? If I try 36 divided by 108, that also reduces down to 1/3. You could do it on a calculator. So your common ratio is R. So is it arithmetic? No, because there's no common difference. Is it geometric? Yes. So why is it geometric? It's geometric because there's a common ratio. Of 1/3. Again, arithmetic has a common difference. So if you did try to take away 3/2, take away 3, did that on a calculator, 3/2 take away 3, you would get negative 1.5 or negative 1.5 or negative 3/2. And then if you tried something like 3/4 take away 1, it's not going to be a constant or a common difference. It's not going to be negative 1.5. Sorry, I didn't put the negative. So there is no common difference. Okay. Now if you try a common ratio, so if you take a number and divide it by the previous number, so if you take like 3/2 and divide it by 3, 3/2 divided by 3, that's the same thing as 3/2 times the reciprocal of 3, which is 1/3. That becomes 1/2. So maybe the common ratio is 1/2, but when you test a different one, like 3/4 divided by 1, that doesn't give you 1/2. So there is no common difference, there is no common ratio. So number 7 would be neither, because there's no common difference, there's no common ratio. Let's move on to the next one, number 8 right here. It says find the next 3 terms. Now they tell you that it's geometric, which means that there's a common ratio. Okay? So what we need to do is use that common ratio to find the next couple of terms, the next 3 terms to be exact. So let's take a look at number 8 and let's identify the ratio, the common ratio. How do you find the common ratio? It says right here on the board, it says to find R, pick a value, then divide it by the previous number. So on number 8, if you pick a number like negative 15 and then divide it by positive 3, negative 15 divided by positive 3, that's negative 5. So the common ratio is negative 5. And then you could use that common ratio to find the next terms. Like for example, that first number 3 times the common ratio, negative 5, that gets you to the negative 15. And then if you take negative 15, multiply it by negative 5, that'll get you to the negative 75. So what would the next number be? On a calculator, you're going to take 75 and multiply it by negative 5. So what would that answer be? Negative 375. So that's technically your fourth term. Now you still need the fifth and the sixth, right? Because they want the next three terms. So take negative 375 on the calculator and multiply it by negative 5 again. What do we get? 1,175? 1,800, sorry. 1,875. Okay, now take that number and multiply it again by negative 5, by the common ratio negative 5. And what do we get? Negative 9,375. And that's it. Those are the next three terms. So we didn't have to come up with the a sub nth rule. Once you know your common ratio, you could use that common ratio to multiply each number to get to the next number. So if I go 3 times negative 5, I get here. If I go negative 15 times negative 5, I get 75. And so on and so on. So it's all about multiplying by your common ratio. Let's take a look at number 9. What's the common ratio on number 9? What's the common ratio on number 9? It's 1/4, right? If you take the number 2 and divide it by 8, right? If you take the number 2 and divide it by 8, that'll be 2 over 8, and you could reduce that to 1/4. So that's your common ratio. Your common ratio is 1/4. And the common ratio describes how one number changes to the next. So if you look at that first number on number 9, 32, if you multiply 32 times 1/4, it'll give you 8, the second number. If you take 8 and multiply it by 1/4, it'll give you 2. If you take 2 and multiply it by 1/4, what do you get? 2 times 1/4. And you could put it on the screen, or you could put it on your paper, 2 over 1 times 1/4. That'll become 2/4, which is really half. So that is your next term. So the next term is 1/2. Now we need the next three terms. So how do I get the next term after the 1/2? I multiply by what? By the common ratio, 1/4. Now what is 1/2 times 1/4? 1/8. And then, so the next number was 1/8. And now how do we find the next number after that? Multiply by 1/4 again, which gives you 1 over 32. And ladies and gentlemen, we found the next three terms. So this is what they're asking for. That's your answer right there. On number 8, those huge numbers were our answers right there. And let's move on to number 10, simplifying radicals once again. Sorry about number 12. There's like 2 problems right there on number 12. But let's take a look at number 10. That's not a square root. That is a fourth root, okay? So what number 10 is asking is, what number times itself 4 times will give you 2,401? On your calculator, you could simply start guessing. You could say 5 to the 4th power, see what it gives you. Now, if you did do 5 to the 4th power, that gives you like 625, right? So then you know that 5 is too small, so you guess something larger. So Brianna, you just said 7, and that's correct, right? 7 to the 4th power is 2,401. So that's it. If they're asking for the 4th root of that huge number, it's just 7. So number 10, the answer is 7. Now remember, on number 11, they give you a rational exponent. What does the 1/3 power actually mean? It's a cube root. I'm going to put a 3 inside of the root, or on the notation of the root, and then 729 on the inside. So I'm really asking what number times itself 3 times gives you 729. So you could use a calculator and pick a number, multiply it with itself 3 times, and see if it gives you. We know it's 9. Because 9 to the 3rd power gives us 729. Let's move on to number 12. There's 2 problems. Should we do both or just pick one of them? Pick one of them? Okay, which one do you want to do? The 243 or the 1024? 1024, all right. So it is a 5th root, okay? So what we're going to do is split the 5th root of 1024. Hopefully that's a nice number. And then we're going to do the fifth root of a to the 11th. And then we're also going to split that fifth root to b to the 17th. Now remember, a fifth root is the power of 1/5. Yes? So you want the inside exponent to be divisible by 5. Anyway, but before doing the exponents, let's just look at the fifth root of 1024. On a calculator, what's the fifth root of 1024? 4? So if you go 4 times 4 times 4 5 times, it does give you 1024. So the answer, the first part of your answer is 4. And now for this guy right here, I want that 11 to be a multiple of 5. Okay, so I'm going to rewrite this. I'm going to rewrite it as the fifth root of a to the 10th times the fifth root of a. It froze again. Okay, so the fifth root of a to the 10th. What is the fifth root of a to the 10th? A squared. And then the fifth root of a up there, we're just going to put that in on our answer as a radical. Okay? But before we do that, let's take this other one. Let's do the fifth root of b to the 17th. Now, I don't want b to the 17th. I want something that's divisible by 5. So what am I going to change on it to? Okay, so I'm changed to 15. But how am I going to do that? I'm going to say the fifth root of b to the 15th times the fifth root of what? b to the second. Because b to the 15th times b to the second, that really is b to the 17th that we had originally. Anyhow, what is the fifth root of b to the 15th? That is b to the third, no more fifth root. And the other one, the fifth root of b squared, that's just going to stay the fifth root of b squared. So our answer is going to be what we have first on the outside. So on the outside we have a 4a squared right here. We also have the b to the third. And then we have all the roots that we had left over. So we have this fifth root of a. Let me write that down. The fifth root of a, but I'm going to put them all together because I also have the fifth root of b squared. So the fifth root of a and the fifth root of b squared, that is our final answer right there in black and red. 4a squared b to the third times the fifth root of a b squared. Equation for the nth term of the geometric sequence. What you need to know is this. You'll be able to create the a sub nth rule. You'll be able to write the equation. So what we need to know, let me actually zoom in and let me rewrite the a sub nth equation. And that's a sub n equals a sub 1 times r to the n minus 1 power. So what we need to know is that a sub n is just the name of your equation. And then a sub 1 is actually your first term on your sequence. We should know that a sub 1 is the first term on the sequence. So that would be 896. So you put 896. And then the common ratio r to the n minus 1 power, we need to find what that common ratio r is. And how do we do that? You simply pick a number and you divide it by the previous number. So if you did do 224 divided by negative 448, that will reduce down to negative 1/2. So the common ratio is negative 1/2. Ladies and gentlemen, this is one of your answers. This is your a sub nth rule. This is your equation that actually produces the above list. So what do I mean that this is the equation that produces this list? Remember, this is just the name of the equation. But if I wanted the first term, of this list, I would have to plug in a 1 right here. If I did plug in a 1, it would be 1 minus 1, which is 0. 1/2, anything to the 0 power is 1, and 1 times 896 is 896, and that's why we get that first term on the list. If I want my second term on the list, all I have to do is plug in the second, or the number 2 right here, and that'll actually give me negative 448. If I plug in the number 3 right here and work out the math, it'll actually give me the third number right here. If I plug in the number 4 right here, it'll actually give me the fourth number. If I plug in the number 5, it'll give me the fifth number. So this is one answer, the equation that they're asking for. This is the equation that produces the list. But they are asking for a second part, they're asking for you to find the 8th term. As you could see right here, it says find the 8th term. So what they actually want us to do is to find the a sub 8th term. Now again, that's just notation saying that you're going to plug in the number 8 in place of the n right here. So let me rewrite my whole thing. Let me actually make it nice and neat here. A sub 8th equals 896 times negative 1/2 to the, and we're plugging in 8, remember 8 minus 1 power. Okay, so all we need to do is work this out, and we'll have the 8th term of the list. So let's work it out. I'm going to rewrite it, and I'm going to use the calculator. So when I rewrite it, it's going to be 896 times negative 1/2 to the power of 7. If I do this on the calculator, it'll actually give me the 8th term on this sequence. And if you type that all in correctly on a calculator, it'll give you the answer to be -7. So believe it or not, your 8th term on this list is -7. So once again, this is a two-part question. They want the equation, and they want the specific number that they asked for. They might ask for the 8th term, the 9th term, the 10th term. All you got to do is plug in that appropriate number into your equation, and it'll give you that number. So number 14 says, write an equation for the nth term of the geometric sequence. Once again, when they ask you to write the equation for the a sub nth term, you need to have it memorized that a sub n is really a sub 1 times the common ratio r to the n minus 1 power. And we should all know that a sub 1 is really what? The first number on your list, which is what? 2. So you really have 2 right here. And now we need to find r. Now what is r? It's the common ratio. And on the board it says, how do you find the common ratio? It says to find r, pick a value, then divide it by the previous number. So if I take 16, negative 16 that is, and divide it by 2. If I take negative 16 and divide it by 2, what do I get?
8.
I get -8. So ladies and gentlemen, r is -8. Now you don't have to check it with the other numbers because they already tell you that it's geometric, right? So just do 1 and you'll know the common ratio is -8. So inside the parentheses, right here where the r belongs, that's where we're going to put a -8 right there. And of course, it's to the n minus 1 power. And this is just a sub n. A sub n is just the name, okay? This is the equation that they're asking for. They're saying write an equation for the nth term. This is called your a sub nth equation, okay? This is the equation that will produce this number, or this list of numbers, this sequence. For example, if I plug in a number 1 where the n is at, and I do the math, it'll give me the first number 2. If I plug in the number 2, it's going to give me the second number. If I plug in the number 3, it'll give me the third number. If I plug in the number 4, it'll give me the fourth number. Does that make sense? They are asking for the 9th term. So this right here, a sub 9, okay, this is just notation. All this is saying is that I'm going to take my a sub nth equation and I'm going to plug in 9. So when I actually plug in 9, it's going to be 9 in place of n, and you still have the -1. Now, if I work out all this math, which the calculator actually does for us, it'll actually give us the 9th term on this sequence. So I'm going to type it into the calculator like this. 2, parenthesis, -8, and then to the power of 8. 9 take away 1 is 8. Now, if you're using the Texas Instrument, you have to use the caret button, and you have to use the negative button, not the minus button. On the Casio, it's a little easier. Well, let me type it on the Texas Instrument here. And on the calculator, we get a huge, huge number. We get 3355442. Yeah, that's my phone number. I'm just kidding, it's not. No, I'm joking. So 33,554,432. That is your 9th number on this list. Now, why is that a huge number? Well, because the common ratio is -8. So you're like multiplying by 8, multiplying by 8, multiplying by 8, multiplying by 8. Of course, it's going to be a huge number by the time you get to the 9th number. anyhow, I'm going to stop this video right here. And on the next video, we're going to jump to more square roots, more solving.